Hey everybody, welcome back. Today we're going to be talking about linear functions. Yes, I know that we started the linear functions chapter last episode, but really that was just a generality of functions, like linear functions, square root functions, cube root functions, rational functions, quadratic functions, all types of functions out there. Right now, we're just going to be focusing on linear functions. Now, what exactly is a linear function? It is a function that can be written in the form y equals mx plus b and is not vertical. The graph is simply, the graph is a non-vertical line. Alright, so linear function has an input x and an output y. The line is the graph. If it's anything other than a line, it is not, or if it is a vertical line, it is not a linear function. Notice that vertical lines are not linear functions because, well, they're not functions. Because, well, it's a vertical line. The x value has several values of outputs, and that breaks the rules of the definition. So you need to have a non-vertical line in order to be a linear function. So anyways, here's an example of what a linear function looks like. So I tried my best to draw a straight line here. This is a linear function because, well, it's a straight line. It's got a constant slope, which is simply rise over run, and the rate of change never changes. All right. Here's an example of something that is not a linear function. This is what we call a quadratic function, which we're going to get to later in Algebra 1 or Algebra 2 if you are simply reviewing stuff in linear functions before you get to all the other stuff. But anyways, this is a quadratic function. Notice that we got a curve and it is not a line. So this is not a linear function. So this is a linear function. No, like I said before, non-vertical lines are linear functions, not vertical line. This is a vertical line, probably about like x equals 3.1 or so. Try my best to make x might equals 3. Actually, I didn't really try. But anyways, this is not a linear function because an x value, it says there's only one x value, and it has several different outputs, infinite number actually. Anyways, that hopefully should give you a good idea of what linear functions really are. Now, how about if you're not given a graph? Okay. Let's say you have something like this. Like this. Like this. So, you have a table. Here we have a very simple table. We have x values and y values. As we go from left to right, x values are increasing by 1 in each cell. 1 plus 1 plus 1 plus 1. Simple. And then same thing here, plus 1 plus 1 plus 1. So Every time x increases by 1, there is a constant change in y, in this case plus 1. That is a linear function. Now, how about something like this? Now, what is this? What is this? So we have x values increasing by 1, same as the table above. However, look at the y values. We are subtracting 4 to get this, adding 4 to get this, and then subtracting 4 to get this. You cannot change this. That is not a constant rate of change. Constant rate of change. You could say that we're multiplying by -1 each time, but that has nothing to do with trying to identify linear functions. So this second table we have does not represent a linear function. All right, let's try something harder. Try this. So we are skipping x value, skipping 2 x values here. So you really need to take that into consideration. The easiest way to figure out if this is a linear function is to see if first see if there are any consecutive x terms. In this case, we have 3 and 4. All right, so we have an increase of the x variable by 1, and then here we have an increase of plus 3 for the y variable here. Now, we still need to figure out what is in between. So 1 and 3. So remember, so hopefully we should see x equals, if x increases by 1, y increases by 3. If that is not the case, then it is not a linear function. Now, we have an increase in 2 here between these two columns of cells. All right. So because we have an increase in 2 for the x variable, we need to take the difference of 8 and 2, and then divide it by 2, and you should get plus 3. So you should get plus 3 as the answer. And so if you were to add a column to this table and you get 2, 5, this would make this a linear function. Now let's check this side. 6 minus 4 equals 2, so we need to work with 2 again. 17 minus 11 equals 6, divide by 2. And 2 and you get 3, so we should have 5, 14, 6, 17. So there you have it, folks. If x increases by 1, y increases by 3, this is a linear function. Pretty interesting, guys. Alright, so now I'm going to give you some equations. And you're going to tell me if these are linear equations. So here's my first. So I'm going to turn on my linear equation setting, and there you go. Is this a linear function? Remember that a linear function can be written in the form shown above: y equals mx plus b. You're going to learn what that really means very soon. But anyways, can you rewrite this as y equals mx plus b? Yes, we can do that. do that. Here's how we do it. We subtract 3x from each side. You should have 4y equals negative 3x plus 6. And then y, divide each side by 4, y equals negative 3/4 x plus 3 over 2. So that's y equals mx plus b form. So this is indeed a linear function. How about this one? Sorry, I'm having a little trouble here. Don't worry, I got it. Is this a linear function? No, it is not. Y equals x squared plus 2x plus 1 is not a linear function. Not a linear function. This is what we call a quadratic function, which we're going to be talking about. I'm talking about later. It's an algebra 1 talk primarily. How about this one? Is this a linear function? No, it is not. This is actually what we call an exponential function. This is also an algebra 1 topic, and the graph looks something like this. It's a little hill function. That's the way, as my math teacher used to call it. All right. How about y equals 4x plus 7, whatever. Yes, this is a linear function because this is in slope-intercept form. All right. This is the last one, guys. How about y equals 2x squared plus 4x divided by 2x? Alright, so is this a linear function? No, this is not a linear function. However, there may be a stumper to this. I'm going to see if I can pull up Desmos real quick. Alright, how do I do this? 2x squared plus 4x divided by 2x. Alright, so look what we got here. We actually got a line. But now, why did I say this was not a linear function? Look at that right there, that little point at 0, 2. See that right there? Undefined. Because if you actually try to plug 0 in for x, you get something over 0. You can't divide by 0, so we have an undefined y value for x equals 0. Linear functions have to have an infinite domain and range. So if you got a little hole like what I just showed you, you do not have a linear function. So that is a pretty good catcher, actually. All right. Now I'm going to talk about discrete and continuous domains, and why they are significant. Okay, so I talked a little bit about this in my previous video over functions, but I'm going to do it again. All right, so a discrete domain represents only certain numbers for x in a function. Now, think about where we would have certain values of x in a function. I'll tell you mine. imagine I'm trying to collect money, and y equals the profit made. How profit made? Profit is the money collected is equal. The profit made is used for tickets to a carnival. And well, let's say that it costs $2 per ticket. Now, can you split up a ticket? No, you cannot split up a ticket and get part of $2. So this is where we can only use certain numbers in the domain to describe this. In this case, it would be whole numbers. So if we were to graph this here, it would look something like this. This point I'm drawing right here is the point for 0 tickets given away, and then this point right here makes this point for 1 ticket given away, and then point for 2 tickets given away. $2 for 1 ticket, $4 for 2 tickets. Can't take any decimals or fractions, so this is simply the graph of the function. So whenever you're in situations where you can't split up an x value, you need to make sure that you do not count in the unnecessary variable numbers. So we cannot do negative numbers, because we can't do negative tickets. And we cannot do integers or fractions or decimals for x values. Sorry, I'm getting a little sloppy. Alright, hopefully this gets better. Anyways, continuous domain, where all values of x take part in the function. Now, where can we have a continuous domain? This domain. Ooh, I got one. Remember the simple interest formula, I equals PRT? Well, I equals PRT. So let's say that we have an unknown I and P value, but we do know that the interest rate is about 5%. We need to write this as a decimal. And then let's say that we have this for 10 years. So there you have it. I and P are your variables. Remember that P is the principal value, or the amount you put into your account before it starts gaining interest. Now, can you take part of dollars? Yes, this is a case where you can actually do that. So, I can actually do that. Remember that cents are parts of 100, parts out of 100 of a dollar. So, we can simplify this to 0.05 times 10 equals 0.5 p. And for cases where you have a continuous domain, this is what it would look like. Now, we'll tell you that this is sort of restricted to positive numbers, but it still includes all decimal and fractional values for p. So let's just say that this is, so because this is a continuous domain, I messed up, sorry. So this is what the graph of the function would look like. I tried to make this as linear as possible. So anyways, that is the graph of the function for simple interest. Notice that we cannot do any negative numbers because money cannot really be negative. Alright? So, felt like that was a terrible video, guys, but I hope that you actually learned something from my sloppiness. Really apologize. Hopefully things are better next time. Anyways, so thank you so much for watching. Be sure to leave a like and subscribe to my channel. And if you really like this video or any of my other videos that I've made, please tell your friends about them. I want to help out as many people as possible, okay? So thanks again for watching, guys. Have an amazing rest of your day. Alright, see you later.